So let's try a problem using what we've learned so far. This is problem number 1338 in your book. Okay. A 0.8 meter diameter 50 kg flywheel with a radius of gyration of 0.283 meters must be braked from 60 RPM to rest in 2 seconds. Calculate the tangential force required to accomplish this braking action. Okay, so this is the flywheel. The diameter is given as 0.8, so the radius is 0.4 meters. Mass is 50 kg. Radius is 0.4 meters. The radius of gyration is given as 0.283, but even if it was not given, we could have calculated it. It starts at 60 RPM, so omega naught, initial angular velocity. Let me write it here. Initial angular velocity. This is the same as u or v naught in the linear world. 60 RPM, which of course means we need to calculate that in radians per second, but we'll do that later. Final is 0. It's going to rest in time 2 seconds. Okay, so 60 RPM, 60 times, so 60 RPM means 60 revs per 60 minutes, 60 seconds, right? Per minute is 60 seconds. I'm just going to write it like this. And then 1 rev is 2 pi radians. So eventually you'll get 2 times pi, 60 cancel out, rev cancel out. You get 2 pi radians, that is 6.28 radians per second. Okay. Alright, so now we need to calculate the angular acceleration, because we'll calculate the angular acceleration. From this we'll calculate torque. From torque we can calculate tangential force. This is what we're going to do. Alright, so alpha is what? The final minus initial angular velocity divided by time. So I should have said that as omega. I'm writing formula, not putting numbers yet. Okay, here I'm going to put the numbers. 0 minus 6.28 divided by 2, that's negative 3.14 radians per second square. Okay, so torque is what? I c alpha, right? Or I or IC. Now what we can do is we can use the formula that we have for you can look up the formula for IC for a flywheel, which is a disc. Basically that's half mr squared. You can calculate that and put it here. But if you don't know this formula, then we will use the concept of radius of gyration. K is equal to square root of I over m, right? So K square is equal to I over m, and I is equal to K square m. So here I'm going to say I is equal to K square m, because K is given, m is given, so we don't need to know this formula for this problem. See, either you should know this formula, or if the questionnaire, if they don't want to give you the shape of this thing, right? Let's say it is some weird shape and they don't want you to go out looking for this formula or come up with a formula for that shape. Simply all they have to do is give you the radius of gyration and the mass. Of course the mass is given. Doesn't matter what this body looks like, of course you would know the mass. and then if you know the radius of, if they give you the radius of gyration, then you don't need to look up any tables or anything. So that's the point here. Okay, k is given as 0.283, right, square. M is 50 kgs, and alpha is 3.14. Negative 3.14 doesn't matter, because this is, we're just the direction of that torque. We really don't care about the direction. Okay, so when you run these numbers, you get 12.57 meter square kg per second square, or that is the same as 12.57 Newton meter. Okay, so now that's the torque. From the torque, if you have a wheel, and that's the torque, okay, torque T, if you take that and divide by that radius, by the distance d, right, then you get this force. So torque is the same as moment, right? Torque is the same as moment. It's just that when things are spinning, we give that moment a special name called torque. Moment is what? Force times distance. Torque is also force times distance. It's just that when you say torque, you use the term torque especially for things that are spinning, but you could call it anything. Basically, it's force times distance. So to get this force, you take this torque divided by that distance, you get the tangential force. Okay, tangential force is torque divided by R. So 12.57 Newton meter divided by radius 0.4 meter, 0.4 meter. So when you do that, you get 31.43 newtons.